full-time job and do what she does, you know. So timers. So why do we do timers? Oh yeah, I was working with somebody.
Oh,
The test for next week.
so that we don't,
You could have,
so we don't fail. Fire.
a preview.
Oh, that's what I got. So we're looking for timers. Timers. So this is in your motor controls book. If you kept that, if you need some place to read, this covers it really well. And while we're doing, of course, when we get into your design, which is lab 3, so the way it usually works is we have 2 labs where you do stuff with, and then the 3rd lab is your design lab, where you've got to figure out how to come up with a control circuit to do that. What it does, it deals with timers. We have 2 broad categories of timers. Anybody know what they are?
Timer on, timer off.
Yeah, on, we call them time on, we call off delay timers and on delay timers. So all the timers will usually fall into those categories. Then we got special purpose timers like cycle timers and that kind of stuff, which basically would be on their category themselves. So this talks about the major categories: dashpot timers. That is still on. Dashpot timers, synchronous timers, solid state timers, and programmable. We're going to be using a programmable timer. What advantage do you think a programmable timer has? Well, a programmable timer can be programmed to do any of these. Yeah. Okay, y'all understand that? Yeah. Not necessarily faster, but I've got one timer, and they're more accurate too. Well, I got one timer that would take the place of one shots. It takes the place of retriggerable one shots. It takes the place of cycle timers. It takes the place of on delay timers or off delay timers. So instead of me having all these different timers and spare parts, I can have one that does everything. So one of the things, programmable timers could fall in this category right here too. So PLCs are programmable. So this is basically the way a dashpot timer works. What we do is we have a fluid or we have an air, and we basically control the size of the orifice that the air has to escape through. Right? You understand that? If we control the flow rate, then we can control the timer. We call these dashpot timers. So we got to have some prime mover that moves it in one direction, and then springs or something else that does what? Pushes it back in the other. So dashpot timers, so this is the dashpot timer. Let me bring my camera back up, and I'll pass these around. What's going on? So this is the camera. Yeah, this application is a lot better. But I can't remember how to get it. I can't remember how to get it up there. Once it's been up there, it don't want to come back up. There we go. And then make sure the right source is there. I just need to read this. Oops, that resolution. And then we'll go full screen. So normally what you'll see on a dashpot camera, not camera, a dashpot timer, you'll see an adjustment on it. And what do you think you're doing with this? You're adjusting the size of the orifice. So we use the relay to cause it, the coil to cause it to either start timing or don't time, right? Now this one right here is a heck of a lot clearer because this right here is made up of both of them. So here's our relay coil or our solenoid coil right here. right? You understand? And then we have 2 dashpot timers on this side and that side. And then somewhere we have a what? Adjustment. So you manually, so if you wanted 2 seconds on this thing, what would you have to do? You have to get your stopwatch. Literally get your stopwatch and adjust it till it gave you a certain amount of time. And also, if it uses air, sometimes the density of the air changes with seasons. So we had one down on the number 4 galvanizer line that burnished. What they did was they welded the 2 strips together. So what they do, that on what we call it the feed end or the takeoff end, they kept one roll that was feeding, then they had to build another roll of 10, a row of 10 that was sitting and riding on top of the other. When it would come to the end, they would stop the line. They would have an end shear. They would shear off the part that was there and get it nice and straight. They'd bring the other one up there and shear it off. They'd overlap them probably maybe an inch. And then they had these big old copper wheels, solid copper wheels, that would come in and clamp those strips between each other, and they would roll across there and it would weld it together. Used a big Ignitron tube. It was really, really neat. Then it would come back and the burnishing tool would come in and burnish or clean off those big copper wheels. They didn't, and the timer was on how long it burnished. If we left it on there too long, it would burnish the wheels and the wheels would wear out too fast. If we didn't leave it on there long enough, it wouldn't burnish enough. It'd have little pits in the copper and it wasn't well right. And we'd have to go back when it changed seasons. And that's one thing the operators would get down there with a stopwatch and watch. And they would check that thing constantly. You might see where the batteries are. That's one problem I thought my grandkids call it my crazy. My youngest granddaughter says I have a crazy rig. It does about what it wants to. So, this right here, and I'll pass this around and let you look at it. So you can manually move the armature in. And you can see what happens is when I do that, did y'all hear the limit switch over here click instantly? This little switch right here click instantly. So it didn't time that. So when I energize it, this guy over here is not timing. It energized instantly, right? You understand? When I let this go, you can actually see it start moving. See it moving? Then you heard it click, right? So this one timed on de-energize, right? So we call this an off delay time. This one on this side, when I energize it, we'll energize the armature. See it start moving now? So this would be an on delay time. Y'all understand that?
Yeah.
So one of them times when you energize the coil. One of them starts timing when you de-energize the coil. Everybody understand that? And of course, if I wanted to change the time, I would come up here and do what? Either change, and what are you doing? You're changing the size of the orifice, which determines the flow rate that fluid goes through on each side. Very straightforward. And we do timers a lot. Your car, if you got a newer car, your car's got timers all over. Most of us now, we don't even worry about our headlights because we put our headlights on. A lot of them. They turn on when you crank your car, and then when you get out, they stay on. So what would that be an example of? Well, that's going to be what we call an off delay time. So you turn your car off, and then the timer starts, right? Y'all understand that? So my dome lights come on when I open the door. When I close the door, the dome lights don't go off instantly. They do what? They time. So off delay and on delay. So normally, when we start motors, if we got multiple motors we want to start, we don't want to start them at the same time because of that inrush, right? You understand? So what we do is we stagger start the motors. So that would be an on delay timer. We might start motor 1, and then 30 seconds later we might start motor 2, and then after that we'd start motor 3, Because if we try to start all those motors at the same time, it's going to take a lot of inrush current, right? If we don't control that or go through reduced safety start. So it's very, very popular to use timers all over the place. So when we draw the contacts for these timers, okay, so notice here what I'm doing is I'm drawing it down like this. And what I'm going to do is I'm going to put an arrow up on it. Okay, I could come over here and do this and draw the arrow away. So the direction of the arrow is determining if it's an on delay timer or an off delay timer. So the coil does not indicate what type of timer it is. What type of timer is indicated by the contact symbols. Everybody understand that? Anybody know what this one is? Yeah, this is timed on, or what we call an on delay. So this guy right here is what? Yeah, this is timed off, or what we call an off delay. Okay. So what would happen on this one is if I energize the coil, this is going to close instantly. I'm sorry, this is going to do what? It's going to close after, it'll open instantly, but it's timed when we energize. Don't understand that. On this one, if I energize the coil that controls this guy, it's going to close instantly, and then when I de-energize it, it's going to start timing, right? Y'all understand that? Yes or no?
Yeah.
So we would say this, we abbreviate this, normally open, timed closed. Over here we'd say this is normally open, timed open. So off delays, they're the same. Normally open, timed open. On delays, they're always backwards, right? You understand that? So this would be a symbol. So what would this be a symbol for? I'm going to come over here. I'm going to draw it above, supposed to touch. Then I'm going to come over here. So this would be a normally closed, timed open. So what would this be? No, this would be a normally closed, timed closed. So your off delays is going to be the same on both sides, right? You understand that? Your on delays, they're going to be opposite. So the lights would be a normally open, timed open. So when you turn your lights on, or when you turn the lights on, that thing closes instantly. The lights comes on instantly, right? You understand? Then you get out of your car, take your ignition out, get out of your car. This guy right here starts doing timing, and then it'll turn on. So dash spot timers, I didn't bring it over. The problem with dash spot timers is that how do you set the time on? If you wanted a certain amount of time, how do you do that? You have to do it with stopper. It's something about bubble wrap. That's what they are. Nobody. Two bubble wrap. Somebody can do that.
I have a coworker that hates it and pop up right.
So what they did is they came up with a timer that used a synchronous motor. Okay, so a synchronous motor is, of course, is a motor that runs at a constant speed, right? And so now you've got a motor that runs, you're not depending on air, you're depending on a motor running at a constant speed. So what can you do now? You can put a dial on it like that. And then you can come in and you can set time, right? Understand? So these were the first accurate timers right here, these synchronous timers. So you just had a knob and you'd come up here, and depends on which direction, whether it's time open or time open, which way it would run. The contacts were digital, right? And of course, usually they would put the wiring diagram on the bottom. So the motor was considered to be the coil. So when you energize this, the motor started running, but the motor would run at a precise speed, right? And if it runs at a precise speed, then we can gear it and do other things to get a time the way we want it. So instead of me guessing at the time now, what could I do? Yeah, I can just come up here, you know, I don't know if this was 40 seconds, 40 milliseconds, I don't know that. But I could just come up here and set a time, and now my timer was active.
40 minutes.
Okay, yeah, I see it now, sorry. Yeah. Pretty neat. And this was called a what? Synchronous time. So you might run into these out there. These would give us, so we use a lot of dashpot timers if we're not concerned with a lot of precision, right? So if we say, okay, I want it to run for about 10 seconds, then a dashpot timer will be fine. If I want to make it run for 10 seconds, whether it's June or July or August or September, then we need something that's a lot more accurate than the cycle. I'm sorry, a dashpot. But look at how big those things are, because it's got to have that motor in there, right? So then we went to solid state timers, guys, and I don't see a. So you can get off delay timer, solid state timers. You can get on delay solid state timers. These guys are timed off electronics. AC probably times off the AC line. So the AC line is very, very powerful. I mean, very accurate. But a lot of times you're going to run into these timers we call cycle time. Now the problem with solid state timers, these guys have to be powered, right? Y'all understand that? Yes or no? So we don't have problems with on delay. So a programmable timer or a solid state timer, off delay, not on delay. We got no problem with on delay. Y'all understand that? Because on delay, oops, let me get this in there. I get it. Escape. Okay. So if I lost anybody, everybody okay so far? So solid state, we have L1 or control L1 and then control L2, right? Okay, are we okay? Now, an on delay timer, we would have no problems. I'm just going to put a push button here. Okay, so this would be my timer. Now, is that solid state? That could be a dash pod. That could be, you know, a synchronous timer. So on the synchronous timer, the coil would be the motor, right? You understand? On a dash pod timer, that circle would represent the coil. On a solid state timer, that circuit would represent the electronics that we have to power up to cause the solid state thing to work. Everybody okay? Now on delay, we have no problem, because when I press the button, it would put power onto the timer, and the timer would start timing. The problem would be if this right here is an off delay timer. Well, if it's an off delay, it's supposed to time when I take power off the coil. But if I take power off the electronics, it's not going to work because the electronics don't have any power. So what does that mean? Yeah, so that means, so off delay, we're going to have this right here, right? You understand that? Yes or no? Okay. We still got a problem in that I'm losing L1. So the way a solid state timer works on an off delay is we have to do it like this. So we call these timers that has no connection, power connection, these are called voltage control timers. But how am I going to do off delay? Because if this guy right here ever opens, I don't care, even if I do run something to L2, if it's open, I lose power to my timer, and it cannot time. Okay. So what we do is we come over here and we do this on these timers. Well, how can it time now? Well, what we do is we add two more things on here that we put a contact right here. And we don't call it off delay and on delay. We say it's going to time on make, or we say it's going to time on break. So either we're going to have to put a push button in there, or we're going to have to put some type of control. So if I set it up on time on break, and then this right here is a control relay, and this contact right here is controlled by CR. Well, when I energize CR, that contact's going to close, but it don't start timing when that contact makes. It starts timing when that contact does what? Breaks. Okay, y'all understand that? So right now, the time is controlled by CR. So it's off delay and on delay by your control relay, right? You understand? These are called contact control timers. And that's the only way you can run a solid state timer as an off delay timer. Everybody understand it? Have I lost anybody? Speak now.
Are PLCs being utilized more time?
Well, I don't know what you're saying. In an automated manufacturer, and odds are all your timers are PLC. But if I'm going over to my house and I want to make my back porch light stay on for 10 minutes, I'm not going to go out and buy a $300 PLC. Understand? So it depends on the application of the timer. So yeah, these timers are still all over the place. Understand what I'm saying, Larry? So yeah, you know, if I'm working for Mercedes, all their timers are going to be inside a PLC. Well, I'm not going to say that. Most of their timers are going to be inside a PLC. But if I just need something, so I'm running a door and I want the door to close after 10 minutes. I'm not going to go out and buy a $1,000 PLC to keep a door open for 10 minutes. So it all depends on how complicated the application is, right? You understand? So yeah, PLCs a lot. PLCs, the timers are in there, and they're available. They act like voltage control timers. But if I'm going to do a solid state timer, which is probably more popular, why than these guys? Because they're accurate. You can see they would be a heck of a lot cheaper than that big old synchronous timer. Just looking at the size of that thing, you can look, well, good gracious, that thing's going to be what, $200 or $300 for that thing. You can get an off delay timer, solid state. On delay, we got no problem. It's these off delays where we got to keep power on the radio. I got to keep power on the radio, right? You understand? So y'all have an off delay timer on y'all's radio too, right? So now if you turn your ignition off and your radio's on, you can stay on for a while. A little while. So what we would do, so we have a contact control timer. Well, when we're using the dang thing as an on delay timer, all we would do is we would come over here and put our control right here. But what we would do is we would put a jumper across the code. So it's always what? It's always made. So here the solid state time, the programmable timer would act just like a voltage control timer. This if I wanted to be what? I wanted to be a what? On delay. If I want it to be an off delay, then I'm gonna have to power that timer up all the time. So it's gonna have its coil or its electronics. It's gonna have to be between what, L1 and L2, and we use another device to control the timer, and then we put a contact between those two things. Now we're not gonna use all the features of this timer. Y'all know what a one shot is? Everybody know what a one shot is? Yeah, we trigger the timer and it gives us one, it'll go true for a certain amount of time and then it'll go false. It'll give us what we call a one shot. We use these a lot. Then we have a cycle timer. What would a cycle timer do? Yeah, so this guy right here is real easy to see. So this has a motor in it. My motor acts like the coil. I put power across the motor and this sucker right here just starts spinning. And then every time it comes on this cam right here, every time it comes around to this slot right here, the contact would close and then it'll open and it'll close. But as long as I put power on the coil, I'm gonna get a cycle, right? You understand that? So these are cycle timers. So normally the old days, a cycle timer just used a little motor, right? You understand? So one shots, that means when I trigger it, it would give us one shot. And then it automatically goes back to its stable state, right? I understand that. Some people call them monostable multiple state. So here's our programmable timer. Right here. The first thing we'll see is I have this guy over here, if I can get it to focus. It looks pretty good, isn't it? Oops, wrong way. Okay. So we have this switch over here, which we tell it what type of timer we're using. So I've got a recycle timer, I got an interval timer, I have a delay on make. Okay. Then I have a delay on break. Then I have a one shot, and I have what we call a retriggable one shot. A retriggable one shot. So a one shot, if I trigger it, and then later on when I trigger it again, it's still going to complete its time. So if I have a one shot set up for 1 second, I trigger it to start it, it gives me one shot. I trigger it in 50 milliseconds, it's not going to do anything. It's going to honor the first time, right? You understand? So even though my input is pulsing all the time, it's going to time for 10 seconds or whatever I said. A retriggable means if I have it set for 1 second and I trigger it at 500 milliseconds, it's going to start timing from 500 milliseconds out to, understand what we're saying? So retriggable, as long as I'm triggering it, the output will stay true. And it only starts timing after the last trigger. We use these for a lot of things like missing pulse detectors, or I'm looking at parts coming down the line and they're supposed to be a part every 1 second. Well, if that part comes down within 1 second, it'll retrigger and says everything's okay. Well, if there's a part missing, what's going to happen? It's going to let it trigger off. A one shot, it's going to give you that time. It's not going to retrigger. So that's the difference between what we call a retriggable one shot and one shot. So our two ones that we're going to look at is delay on make and delay on break. No, we're not using the one shots in this class. We're not using the retriggable one shots. We're not using the cycle time, which they call the recycle time. But notice this guy right here replaces a lot of timers, right? You understand? It replaces a one shot. It replaces a retriggable one shot. It replaces a cycle timer. It replaces an on delay timer. It replaces an off delay timer. And I can do that with one timer. But the first thing you got to do is what? Set what timer you're using. And then we come over here and we set the time. But what we do down in here, we have a multiplier. So over here I have a thing between 1 and 100. Well, what does that mean? Well, it depends on what type of multiplier I use. Everybody understand? So the multipliers, if I can zero in on this, we got a 0.1, we got a 1, and we got a 10. So if I put it on 0.1, then this would be from 0.1 to 10 seconds, right? You understand that? If I put it on 1, it's going to be from 1 second to 100 seconds. If I put it on 10, it's going to be from 10 seconds to 1,000 seconds. Now what we can do is we can use this guy to trigger another timer, right? So you can think about how long you can make some of these time delays. Here, the maximum on this one, the maximum we got is 1,000 seconds. How many minutes would that be?
So what if you don't move? You have to move.
Yeah. So we got 3 settings, right? Well, first of all, I'm sorry. This guy, first of all, this side, I didn't see this. I forgot about this. This guy's got seconds. This guy's got minutes. So if I put it on seconds, I can set those things to get anywhere from 0.1 up to 10, up to 1,000 seconds. If I put it on minutes, then I've got everything from 1 minute to 1,000. Thank you. I got my contacts in. I can't. My glasses broke, so I'm wearing contacts. Yeah, I'm a crazy leg. Oh, it didn't unplug here. It unplugged here.
You want me to screw it on?
No, it don't.
Okay.
Boom.
No, this don't tighten it up. Really tighten it up.
Yeah, but it's a double thread.
Oh, okay.
You don't have a feed, you don't have a nut on the side. So you can't screw a screw into a screw here. No, even if you tighten it up. So you can't tighten it. Okay, everybody okay? So first thing you'll do on this is set what type of timer you want. If we want to on delay, we're going to set it on delay on make. If we want off delay, we're going to set it on delay on break. I'm sorry, off delay, we're going to set it on make on break. On delay, you don't have to really do anything. All you got to do is come over here and just jump out its contact pins, and I'll show you that in a minute. I keep forgetting I can't. This guy takes full control. So if you want an on delay, so it says I want this thing to happen 10 seconds after this. That's an on delay, right? Well, what we'll do on this guy is we'll set it up for delay on make. So let's say I want to time 10 seconds after that button takes place. Well, what I'm going to do is I'm going to take where my contact connects. So I'm just going to put a jumper there. And now it's an on delay timer. But it's a contact control, right? So what happens when I push the button, it powers the timer up. It's an on delay timer. I got no problem. So it's got power. It's going to start doing what? It's going to start timing. I don't want it to wait for this contact to close. So we're going to set this up for what? Delay on make. And then we're just going to jump it out. So it's always what? It's always made. So as soon as I power the timer up, my electronics has power and it'll start timing. Now off delay, then we're going to have to do what? So a delay on break, which would be, then I've got to come over here and I've got to hook my timer between L1 and L2. And then I'm going to control this contact with either a relay or a push button or whatever. But if I control it with a push button, if I press it down, it's going to energize it. It's going to change instantly, right? And it's going to start timing when I do what? When I let it go, depending on whether we use a normally open or normally closed contact. Well, it depends on what we're going to do. Yeah. Anyway, it's going to start timing when it breaks.
Yeah.
Okay. So I don't know if I can get this to focus in, guys. Y'all might need to go get your timers so y'all can look at them yourself. I wonder if I'll do that. Go to one of the benches and get a timer. And that way, trying to see it on the video, you're actually looking at the timer when I explain this. Everybody got one, programmable timer that y'all can look at. Are we okay? Okay, so y'all see everything, right? So see where you select a type timer you want. In this class, we're either going to use delay on make or delay on break. Everybody okay? Yes or no? No. Okay. Then what do we use we call these dip switches, by the way. What do we use the dip switch for? To set the multiplier. And then once we set the multiplier, we use the knob to actually set the time within that multiplier. Everybody okay there? Yes or no? Pretty straightforward, right? Okay, so y'all look at the wiring. This right here is not exactly right because they put a push button right here. This is actually called initialize. This guy right here in the upper left-hand corner where they got that push button at, this is where the contact goes. And what's the pin numbers? 5 and 6. So if I'm going to run this as an on-delay timer, I'm going to jump 5 and 6. Everybody understand that? And we'll wire it just like a regular timer. If I'm going to run this as an off-delay timer, I'm going to put my control device between 5 and 6, and I'm going to wire the coil. We still call it a coil, but it's the electronics it's going to be. So where's the electronics at? Well, the electronics, you see input, so this is misnomer too. This is not the input, this is the power. This guy will run off AC or DC. Don't make any difference, don't care. It's got a rectifier inside of it. If we put AC on it, it'll work just as good. If I put DC on it, then I've got to honor the plus and the minus. Everybody understand that? If I put AC, so where's our power come in? Our coil control. Our coil is between what? 7 and 2. Everybody understand that? Yes or no? Okay. Now my contacts, I have a single pole double throw. I've only got one contact, right? Where's it at? It's between what? 1 is your pole, right? 4 is a normally closed. So between 1 and 4, I have a normally closed. Between 1 and 3, I have a normally open. Y'all see that? So normally these solid state devices only have how many contacts? I mean, how many poles? 1. You don't have 1 pole. Now they might have a 2 throws, but they usually only have 1 pole. So if you want to control a lot of devices, you're going to use this to control a control relay, right? You understand that? And then how many contacts can you get on that? We have 3 poles on our control relay. So right here where it says input, this is the electronics, right? So this is not the input. You got to honor the polarities. And we're not using DC, so we what? We don't have to honor that curve. So which one you use for your coil makes no difference.
2 and 7.
2 and 7 for the coil, for the electronics, right? You understand. 5 and 6 is what we're doing delay on, make and break. So that's your control. Everybody understand that?
See, that was 5 and 6.
Isn't it 5 and 6? Yeah, 5 and 6. Ours has a push button there. Actually, it's supposed to be called initiate is what it's called. It's going to initiate the timing. So this is a contact control timer. The contact that controls it is between what? 5 and 6. It's just that if I'm using an on delay timer, I go ahead and do what? Jump 5 and 6. Everybody understand? Yes or no? Back. It's going to tidy up. So I don't know what ours calls for. What does ours call for? So it says I want if I want this to occur 10 seconds after, then we're gonna do an on delay timer, right? So what we're gonna do is you'll put your control devices over here between L1 and the timer. Then you're gonna jump what? You're gonna jump 5 and 6. So it's gonna be, you're gonna set it up on delay on make, and you always have it made, right? You understand? Yes or no? So this is the way we simulate on delay, this is the way we simulate off delay, but it's actually, the off delay is controlled by that contact. Y'all have any questions? Yes or no? But when you get into experiment 3, it's gonna start pushing you a little bit, right? Everybody okay? And you're working on this as a team. So when y'all working on this circuit, y'all need to all be on the same, y'all need to be at the same table together, right? And hash this out. All right, y'all go back to lab. Somebody turn the lights back on.